Anytime we have a rational set up in a proportion form, what we're going to do is to cross multiply these. So I'm going to put parentheses around both numerators, and then we cross multiply. We don't have to worry about excluded values on these because there is no variable in the denominator. So we do 9 times x minus 6, followed by 4 times x minus 5. After distribution on both sides, we should have 9x minus 54 equals 4x minus 20. Going to move the 4x over to the 9x. And I'm going to move the 54 over to the 20. So 5x equals 34. And we're going to leave this in the fraction form, 34 divided by 5. On this one, we do have to worry about our excluded values. Remember, it's all about the denominator. We need to make sure we do not have a denominator equal to 0. So our first excluded value is going to be 3. And on the other side, we cannot have 0. So once we've established our excluded values, now we can cross multiply because these are in proportion form. So this becomes x times x squared, x times 6, negative 6x. On the other side, we have 8 times x, 8x, 8 times negative 3, negative 24. So you can see we have a quadratic equation because it is x squared. So we're going to move everything to the same side because regardless of which method we use, we want to have everything set equal to 0. Whether we use quadratic formula, whether we graph, whether we factor, we want those to be equal to 0. Add the 24. So we end up with x squared minus 14x plus 24. Again, you can use quadratic formula or you can factor. Factoring is always going to be faster if it does factor. So we see that the factors of 24 that become 14 would be negative 2 and negative 12, which means we have a solution at 2 and we have a solution at 12. Neither of these values were excluded, so those are true solutions. All right, let's take a look at this one. This one, what we've got to keep in mind, your science teacher probably told you this, and they were right. The most common and useful formula you're ever going to use is equal to distance equals rate times time. You've all heard this one before, I'm sure. All right, distance equals rate times time. So what we have here is a comparison of this, but we have to make sure that we are set to what they want to solve for. It says a person swims 11 miles down river. In the same time, they can swim 7 miles upriver. So right there, we're talking about their distance, right? The speed of the current is 4 miles per hour. So what we're looking for here is trying to find the rate of either of these two. So what we need to do is find out and compare their times, which is equal to the distance, which we know, over the rate, which we know. So let's compare these two. First of all, their time, because it says, remember, it says find the speed, where does it say? In the same time. So that means their time is going to be equal. So time upriver, when is time upriver equal to time downriver? So that's the equation we came up with. They're usually going to say something like that. When will the times be the same? When will the distance be the same? We know we're comparing them to each other. So let's talk about the time. Well, time is equal to distance divided by rate. Distance divided by rate. So what is our downstream distance according to our scenario here? Our downstream distance is 11 miles. So we're going to replace D with 11. And our distance for the upstream is 7 miles. We don't know how fast they are traveling. Excuse me, we do know how fast they are traveling. What we don't know is the rate of the current. Sorry, we do have that. The current is 4 miles. I'm sorry about that. So it's going to be rate. When you're going downstream, you're going to have a current pushing you. So it's going to be my rate plus 4. When I'm going upstream, the current is going to be working against me. So it's going to be my rate minus 4. Follow our reasoning there? So if I'm going 10 miles per hour and upstream, the current's going to be kicking me up to 14. If I'm going 10 miles per hour and current is working against me, 4 miles, I'm only going 6 miles per hour. That's why we're traveling this way. So now we've set up a proportion. Just like the last questions we were doing, we have a proportion here. Our excluded values, our x cannot be equal to 4, but a lot of times just physics eliminate these things. Like it technically is r equals negative 4, but you can't have a negative 4 rate anyway. Can't even have negatives, can't have 0. I guess you could have 0. Current could be flat, no current whatsoever. So what we do here is we cross multiply. That would give us 11r, 11 times the r, minus 11 times the 4, which is 44. And then on the other side, we have 7 times r, 7r, 7 times 4, which is 28. Most of the time when you do these rational expressions, where you move them is pretty self-explanatory. It makes much more sense to move the r over here. That way we'll have a positive number for r. And it makes more sense to move the 44 over there because now we have a positive 72. We divide both sides by 4. What would our rate be? I'm thinking 18. miles per hour. What is 18 miles per hour? That's also the important part about word problems. Not just getting an answer, but interpreting the answer. Usually you just have to go to your last sentence. And what does the last sentence say? Find the speed of the person in still water. So this person's swimming 18 miles per hour in still water. That's a pretty fast swim. But that's what our answer should be. So let's take a look at this one. It says a boat goes 240 miles downstream. And you're going to see most of these deal with stream because we're comparing one scenario to another. Same thing with the earth and flying. What all comes into effect with flying, by the way? Wind, right? What else? Drag. The other thing, you're flying over a moving target. That's why if you fly to the other side of the country, if you go to Australia, you're going to fly with the rotation, and then when you fly back, you're going to fly with the rotation. So you won't be taking the same track because the Earth rotates under a plane as well. So the plane is moving, but so is the Earth. All right. So that's another thing that we have to take into consideration. We know a full rotation is 24 hours. All right. So downstream 240, upstream 160. The speed of the current. So how fast are we in still water? So we basically have the same thing again. We need to see in the same time. If this said the same rate, well, the rate formula is rate equals distance over time. So you end up using the same thing over and over again. So don't worry about that. But this one we are comparing their time, which is distance over rate. So we want the two times to be the same because they said they were. So this is, which is first? Downstream, this is upstream. So the downstream would be distance over rate equal to distance over rate. Well, the distance of downstream is 240. The distance of upstream is 160. The current is 5 miles per hour. We don't know the rate that he's traveling, but if he's going downstream, the current is adding to his speed, and if he's going upstream, the current is subtracting from his speed. Drop those parentheses. When we cross multiply, is that 1200? And then we'll multiply the 160, 160R, plus 800. Like I said on the last example, it's usually pretty self-explanatory where we want to move everything on these linears. I want to move the 160R over here, make the smaller one go to the bigger one. That would give me 80R. And then move the 1200 to the other side equals 2000. We divide both sides by 80. What would our rate be? So our rate would be 25. And again, it's most important that you interpret what you found. R equal to 25 means nothing. Somebody put it into a sentence. 25 is the speed of the boat in still water. All right? If you can, you know, they talk about book smart and street smart type stuff. Your boss doesn't care if you can solve something if you can't interpret what you solved. Be the smartest person on the planet, but if you can't relay what you've discovered, who cares? Who cares? So make sure that you know. And usually, like I said, the last sentence or the second to last sentence will be what you just found.